A little bit about how do we actually apply the law of sines in real world situations. So I've got a couple of examples here to walk through with you, and and with these examples, you will see that we actually can use law of sines, and it can be very helpful to us if we are looking for some specific information. And we've got a triangle to boot. Okay, here's an example. A surveyor needs to determine the distance between 2 points that lie on opposite banks of a river. The figure shows that 300 yards are measured along one bank. The angles from each end of this line to a point on the opposite side are 62 degrees and 53 degrees, respectively. Find the distance between point A and point B to the nearest tenth of a yard. Okay, so we are really looking for the length of this side, also known as side C, right? And we know the measure of angle C. So it looks like that this is a good candidate for the law of sines if we set that equal to 300 yards over the sine of angle B, right? But first we would have to find the measure of angle B. So let's go ahead and do that. Measure of angle B will be equal to 180 degrees minus the sum of 62 degrees plus 53 degrees. And so the measure of angle B will equal 65 degrees. Excellent, excellent. Okay, moving on. Now we can set up a proportion. 300 yards divided by the sine of 65 degrees is equal to C here divided by the sine of 53 degrees. Go ahead and cross multiply. C times sine of 65 degrees is equal to 300 times the sine of 53 degrees. Divide out the sine of 65 degrees and you will have isolated C, and the equivalent expression is 300 times the sine of 53 degrees divided by the sine of 65 degrees. And if I crunch that in a calculator, I end up with about 264.4 yards. So I can say that the distance between angle A and angle B is about 264.4 yards. All right, excellent, excellent. Let's do another one. This is one of my favorites because I love Italy and I really wish I could go. It's my dream. The Leaning Tower of Pisa leans at an angle of about 84.7 degrees. All right. The figure shows that 171 feet from the base of the tower, the elevation, the angle of elevation to the top of the tower is 50 degrees. Find the distance to the nearest tenth of a foot, okay, from the base to the top of the tower. So we're going to go over here to the base of the tower to the top of the tower. So we're looking for this side length, which is side length B. All right. Okay, so we can again set up the law of sines. We're going to use the side length B and the angle measure 50 degrees, right? And then we're going to need to find this third angle again, like we did before, so we can put it in a ratio with 171 feet. All right, let's take a look. Okay, the measure of angle C plus 84.7 degrees plus 50 degrees will all equal 180 degrees. So that means if I subtract off that 84.7 and that 50 degrees, we should end up with the measure of angle C being 45.3 degrees. Excellent. Okay, now let's set up a proportion. All right, using the law of sines. So 171 feet divided by the sine of angle C, or 45.3 degrees, will be equal to length of side B over the sine of 50 degrees. Cross multiply. B times the sine of 45.3 degrees is equal to 171 times the sine of 50 degrees. Divide out the sine of 45.3 degrees on both sides, and then crunch this expression using a calculator. And we end up with a result that side B, or that length on the, it's almost the height, right, of the tower. It's the height of the leaning tower, is 184.3 yards. All right, hope this helps you, and see you next time.